Welcome back. Let's try finish reading. I'm uploading. So it's a bit too late. It's almost 11. I don't know if we can still reading. No, I did pause the reading, but not always. You can start again.
Using plus 9 pounds per square inch, 1.66 atom, 48, boost. In 1940, after receiving a request in March of that year from the Ministry of Aircraft Production for a high-rated, 40,000 feet, 12,000 m, Merlin for use as an alternative engine to the turbocharged Hercules 8 used in the prototype high-altitude Vickers Wellington V bomber, Rolls-Royce started experiments on the design of a two-stage supercharger, and an engine fitted with this was bench-tested in April 1941, eventually becoming the Merlin 60. The basic design used a modified Vulture supercharger for the first stage, while a Merlin 46 supercharger was used for the second. A liquid-cooled intercooler on top of the supercharger casing was used to prevent the compressed air forward/fuel mixture from becoming too hot. Also considered was an exhaust-driven turbocharger, but although a lower fuel consumption was an advantage, the added weight and the need to add extra ducting for the exhaust flow and waste gates meant that this option was rejected in favor of the two-stage supercharger. Fitted with the two-stage two-speed supercharger, the Merlin 60 series gained 300 HP, 220 kilowatts, at 30,000 feet, 9,100 m, over the Merlin 45 series, at which altitude a Spitfire 9 was nearly 70 miles per hour, 110 kilometers per hour, faster than a Spitfire V. The two-stage Merlin family was extended in 1943 with the Merlin 66, which had its supercharger geared for increased power ratings at low altitudes, and the Merlin 70 series that were designed to deliver increased power at high altitudes. While the design of the two-stage supercharger forged ahead, Rolls-Royce also continued to develop the single-stage supercharger, resulting in 1942 in the development of a smaller cropped impeller for the Merlin 45M and 55M. Both of these engines developed greater power at low altitudes. In squadron service, the LF.V variant of the Spitfire fitted with these engines became known as the clipped, clapped, and cropped Spitty to indicate the shortened wingspan, the less than perfect condition of the used airframes, and the cropped supercharger impeller. Carburetor developments, edit. The use of carburetors was calculated to give a higher specific power output, due to the lower temperature, hence greater density, of the fuel forward/air mixture compared to injected systems. However, the Merlin's float-controlled carburetor meant that if Spitfires or Hurricanes were to pitch nose down into a steep dive, negative G-force, G, produced temporary fuel starvation, causing the engine to cut out momentarily. By comparison, the contemporary Bf-109E, which had direct fuel injection, could bunt straight into a high-power dive to escape attack. RAF fighter pilots soon learned to avoid this with a half-roll of their aircraft before diving in pursuit. A restrictor in the fuel supply line, together with a diaphragm fitted in the float chamber, jocularly nicknamed Miss Schilling's orifice, after its inventor, went some way towards curing fuel starvation in a dive by containing fuel under negative G. However, at less than maximum power, a fuel-rich mixture still resulted. Another improvement was made by moving the fuel outlet from the bottom of the SU carburetor to exactly halfway up the side, which allowed the fuel to flow equally well under negative or positive G. Further improvements were introduced throughout the Merlin range. 1943 saw the introduction of a Bendix-Stromer pressure carburetor that injected fuel at 5 pounds per square inch, 34 kPa, 0.34 bar, through a nozzle directly into the supercharger, and was fitted to Merlin 66, 70, 76, 77 and 85 variants. The final development, which was fitted to the 100 series Merlins, was an SU injection carburetor that injected fuel into the supercharger using a fuel pump driven as a function of crankshaft speed and engine pressures. Improved fuels, edit. At the start of the war, the Merlin I-2 and 3 ran on the then standard 87-octane aviation Spirit and could generate just over 1000 HP, 750 kilowatts, from its 27-liter, 1,650 cu displacement. The maximum boost pressure at which the engine could be run using 87-octane fuel was plus 6 pounds per square inch, 141 kPa, 1.44 atom. However, as early as 1938, at the 16th Paris Air Show, Rolls-Royce displayed two versions of the Merlin rated to use 100-octane fuel. The Merlin R.M.2M was capable of 1,265 HP, 943 kilowatts, at 7,870 feet, 2,400 m, 1,285 HP, 958 kilowatts, at 9,180 feet, 2,800 m, and 1,320 HP, 980 kilowatts, on takeoff, while a Merlin X with a 2-speed supercharger in high gear generated 1,150 HP, 860 kilowatts, at 15,400 feet, 4,700 m, and 1,160 HP, 870 kilowatts, at 16,730 feet, 5,100 m. From late 1939, 100-octane fuel became available from the US, West Indies, Persia, and, in smaller quantities, domestically. Consequently, in the first half of 1940 the RAF transferred all Hurricane and Spitfire squadrons to 100-octane fuel. Small modifications were made to Merlin II and III series engines, allowing an increased, emergency, boost pressure of plus 12 pounds per square inch, 183 kPa, 1.85 atom. At this power setting these engines were able to produce 1,310 HP, 980 kilowatts, at 9,000 feet, 2,700 m, while running at 3,000 revolutions per minute. Increased boost could be used indefinitely as there was no mechanical time limit mechanism, but pilots were advised not to use increased boost for more than a maximum of 5 minutes, and it was considered a definite overload condition on the engine. If the pilot resorted to emergency boost, he had to report this on landing, when it was noted in the engine logbook, while the engineering officer was required to examine the engine and reset the throttle gate. Later versions of the Merlin ran only on 100-octane fuel, and the 5-minute combat limitation was raised to plus 18 pounds per square inch, 224 kPa, 2.3 atom. In late 1943 trials were run of a new 100/150 grade, 150 octane, fuel, recognized by its bright green color and awful smell. Initial tests were conducted using 6.5 cubic centimeters, 0.23 mfl ounce, of tetraethyllead, TEL, for every 1 imperial gallon of 100-octane fuel, or 1.43 cc/L or 0.18 USFL ounce/U.S gal. But this mixture resulted in a buildup of lead in the combustion chambers, causing excessive fouling of the spark plugs. Better results were achieved by adding 2.5% monomethylaniline, MMA, to 100-octane fuel. The new fuel allowed the 5-minute boost rating of the Merlin 66 to be raised to plus 25 pounds per square inch, 272 kPa, 2.7 atom. With this boost rating, the Merlin 66 generated 2000 HP, 1500 kilowatts, at sea level and 1860 HP, 1390 kilowatts, at 10,500 feet, 3,200 m. Starting in March 1944, the Merlin 66 powered Spitfire IXs of two Air Defence of Great Britain, ADGB, squadrons were cleared to use the new fuel for operational trials, and it was put to good use in the summer of 1944 when it enabled Spitfire LFMK IXs to intercept V-1 flying bombs coming in at low altitudes. 100/150 grade fuel was also used by Mosquito night fighters of the ADGB to intercept V-1s. In early February 1945, Spitfires of the 2nd Tactical Air Force, 2TAF, also began using 100/150 grade fuel. This fuel was also offered to the USAF, where it was designated ppf 44-1 and informally known as PEP. Production, edit. Production of the Rolls-Royce Merlin was driven by the forethought and determination of Ernest Hives, who at times was enraged by the apparent complacency and lack of urgency encountered in his frequent correspondence with the Air Ministry, the Ministry of Aircraft Production and local authority officials. Hives was an advocate of shadow factories, and, sensing the imminent outbreak of war, pressed ahead with plans to produce the Merlin in sufficient numbers for the rapidly expanding Royal Air Force. Despite the importance of uninterrupted production, several factories were affected by industrial action. By the end of its production run in 1950, 168,176 Merlin engines had been built, over 112,000 in Britain and more than 55,000 under license in the US. Derby, edit. The existing Rolls-Royce facilities at Osmaston, Derby were not suitable for mass engine production, although the floor space had been increased by some 25% between 1935 and 1939. Hives planned to build the first 200 or 300 engines there until engineering teething troubles had been resolved. To fund this expansion, the Air Ministry had provided a total of £1,927,000 by December 1939. Having a workforce that consisted mainly of design engineers and highly skilled men, the Derby factory carried out the majority of development work on the Merlin, with flight testing carried out at nearby IAF Hucknall. All the Merlin-engined aircraft taking part in the Battle of Britain had their engines assembled in the Derby factory. Total Merlin production at Derby was 32,377. The original factory closed in March 2008, but the company maintains a presence in Derby. Crew, edit. To meet the increasing demand for Merlin engines, Rolls-Royce started building work on a new factory at Crewe in May 1938, with engines leaving the factory in 1939. The Crewe factory had convenient road and rail links to their existing facilities at Derby. Production at Crewe was originally planned to use unskilled labor and subcontractors, with which Hives felt there would be no particular difficulty, but the number of required subcontracted parts such as crankshafts, camshafts and cylinder liners eventually fell short, and the factory was expanded to manufacture these parts in-house. Initially, the local authority promised to build 1,000 new houses to accommodate the workforce by the end of 1938, but by February 1939 it had only awarded a contract for 100. Hives was incensed by this complacency and threatened to move the whole operation, but timely intervention by the Air Ministry improved the situation. In 1940 a strike took place when women replaced men on capstan lathes, the workers' union insisting this was a skilled labor job. However, the men returned to work after 10 days. Total Merlin production at crew was 26,065. The factory was used post-war for the production of Rolls-Royce and Bentley motor cars and military fighting vehicle power plants. In 1998 Volkswagen AG bought the Bentley mark and the factory. Today it is known as Bentley Crew. Glasgow, edit. Hives further recommended that a factory be built near Glasgow to take advantage of the abundant local workforce and the supply of steel and forgings from Scottish manufacturers. In September 1939, the Air Ministry allocated £4,500,000 for a new shadow factory. This government-funded and operated factory was built at Hillington starting in June 1939 with workers moving into the premises in October, 1 month after the outbreak of war. The factory was fully occupied by September 1940. A housing crisis also occurred at Glasgow, where Hives again asked the Air Ministry to step in. With 16,000 employees, the Glasgow factory was one of the largest industrial operations in Scotland. Unlike the Derby and Crewe plants, which relied significantly on external subcontractors, it produced almost all the Merlin's components itself. Hillington required a great deal of attention from Hives from when it was producing its first complete engine. It had the highest proportion of unskilled workers in any Rolls-Royce managed factory. Engines began to leave the production line in November 1940, and by June 1941 monthly output had reached 200, increasing to more than 400 per month by March 1942. In total 23,675 engines were produced. Worker absenteeism became a problem after some months due to the physical and mental effects of wartime conditions such as the frequent occupation of air raid shelters. It was agreed to cut the punishing working hours slightly to 82 hours a week, with 1/2 Sunday per month awarded as holiday. Record production is reported to have been 100 engines in one day. Immediately after the war the site repaired and overhauled Merlin and Griffon engines, and continued to manufacture spare parts. Finally, following the production of the Rolls-Royce Avon turbojet and others, the factory was closed in 2005. Manchester, edit. Main article, Ford Trafford Park Factory. The Ford Motor Company was asked to produce Merlins at Trafford Park, Stretford, near Manchester, and building work on a new factory was started in May 1940 on a 118-acre, 48-ha site. Built with 2 distinct sections to minimize potential bomb damage, it was completed in May 1941 and bombed in the same month. At first, the factory had difficulty in attracting suitable labor, and large numbers of women, youths and untrained men had to be taken on. Despite this, the first Merlin engine came off the production line 1 month later and it was building the engine at a rate of 200 per week by 1943, at which point the joint factories were producing 18,000 Merlins per year. In his autobiography Not Much of an Engineer, Sir Stanley Hooker states, once the great Ford factory at Manchester started production, Merlins came out like shelling peas. Some 17,316 people worked at the Trafford Park plant, including 7,260 women and 2 resident doctors and nurses. Merlin production started to run down in August 1945, and finally ceased on the 23rd of March 1946. Total Merlin production at Trafford Park was 30,428. Packard V1650, edit. Main article, Packard V1650 Merlin. As the Merlin was considered to be so important to the war effort, negotiations were started to establish an alternative production line outside the UK. Rolls-Royce staff visited North American automobile manufacturers to select one to build the Merlin in the US or Canada. Henry Ford rescinded an initial offer to build the engine in the US in July 1940, and the Packard Motor Car Company was selected to take on the $130 million Merlin order, equivalent to $2.83 billion in 2023 dollars. Agreement was reached in September 1940, and the first Packard-built engine, a Merlin XX, designated the V1650-1, ran in August 1941. Total Merlin production by Packard was 55,523. 6 development engines were also made by Continental Motors, Incorporated. Variants, edit. Main article, list of Rolls-Royce Merlin variants. This is a list of representative Merlin variants, describing some of the mechanical changes made during development of the Merlin. Engines of the same power output were typically assigned different model numbers based on supercharger or propeller gear ratios, differences in cooling system or carburetors, engine block construction, or arrangement of engine controls. Power ratings quoted are usually maximum military power. All but the Merlin 131 and 134 engines were right-hand tractor, i.e. the propeller rotated clockwise when viewed from the rear. In addition to the mark numbers, Merlin engines were allocated experimental numbers by the Ministry of Supply, MOS, for example, RM8SM for the Merlin 61 and some variants while under development. These numbers are noted where possible. Merlin engines used in Spitfires, apart from the Merlin 61, used a propeller reduction ratio of .4771. Merlins used in bombers and other fighters used a ratio of .421. Data from Brigman, James, unless otherwise noted. 1 Merlin 2, RM1S. 1030 HP, 770 kilowatts, at 3000 RPM at 5500 feet, 1676 m, using plus 6 psi boost, 41 kPa gauge, or an absolute pressure of 144 kPa or 1.41 atom, used 100% glycol coolant. First production Merlin 2 delivered the 10th of August, 1937. Merlin 2 used in the Bolton Paul Defiant, Hawker Hurricane Mk.I, Supermarine Spitfire Mk.I fighters, and Ferry Battle Light Bomber. 1 Merlin 3, RM1S. Merlin 3 fitted with universal propeller shaft able to mount either de Havilland or Rottle propellers. From late 1939, using 100-octane fuel and plus 12 psi boost, 83 kPa gauge, or an absolute pressure of 184 kPa or 1.82 atom. The Merlin 3 developed 1310 HP, 980 kilowatts, at 3000 RPM at 9000 feet, 2700 m. Using 87-octane fuel. The power ratings were the same as the Merlin 2. Used in the Defiant, Hurricane Mk.I, Spitfire Mk.I fighters, and Battle Light Bomber. First production Merlin 3 delivered the 1st of July 1938. 1 Merlin X, RM1SM. 1130 HP, 840 kilowatts, at 3000 RPM at 5250 feet, 1600 m, maximum boost pressure plus 10 psi. This was the first production Merlin to use a 2-speed supercharger, used in Halifax Mk.I, Wellington Mk.2, and Whitley Mk.V bombers. First production Merlin X, the 5th of December, 1938. 1 Merlin 12, RM3S. 1150 HP, 860 kilowatts, fitted with Kaufman engine starter, first version to use 70/30% water/glycol coolant rather than 100% glycol. Reinforced construction, able to use constant boost pressure of up to plus 12 psi using 100 octane fuel, used in Spitfire Mk.2. First production Merlin 12, the 2nd of September, 1939. 1 Merlin XX, RM3SM. 1480 HP, 1100 kilowatts, at 3000 RPM at 6000 feet, 1829 m, 2-speed supercharger. Boost pressure of up to plus 14 psi, used in Hurricane Mk.2, Beaufighter Mk.2, Halifax Mk.2 and Lancaster Mk.I bombers, and in the Spitfire Mk.3 prototypes, N3297 and W3237. First production Merlin XX, the 4th of July, 1940. 1 Merlin 32, RM5M. 1645 HP, 1227 kilowatts, at 3000 RPM at 2500 feet, 762 m, a low-altitude version of Merlin with cropped supercharger impellers for increased power at lower altitudes and a maximum boost pressure of plus 18 psi. Fitted with Kaufman engine starter, used mainly in Fleet Air Arm aircraft, mainly the Fairey Barracuda Mk.2 torpedo bomber and Supermarine CFF Mk.IIC fighters. Also Hurricane Mk.V and Spitfire PR Mk.13. First production Merlin 32, the 17th of June, 1942. 1 Merlin 45, RM5S. 1515 HP, 1130 kilowatts, at 3000 RPM at 11,000 feet, 3353 m, used in Spitfire Mk.V, PR.Mk.4 and PR.Mk.7, CFI and IIC. Maximum boost pressure of plus 16 psi. First production Merlin 45. The 13th of January, 1941. 1 Merlin 47, RM6S. 1415 HP, 1055 kilowatts, at 3000 RPM at 14,000 feet, 4267 m, high-altitude version used in Spitfire H.F.Mk.6. Adapted with a Marshall compressor, often called a blower, to pressurize the cockpit. First production Merlin 47, the 2nd of December, 1941. 1 Merlin 50.M, RM5S. 1585 HP, 1182 kilowatts, at 3000 RPM at 3800 feet, 1158 m, low-altitude version with supercharger impeller cropped to 9.5 in, 241 mm, in diameter. Permitted boost was plus 18 psi, 125 kPa gauge, or an absolute pressure of 225 kPa or 2.2 atom, instead of plus 16 psi, 110 kPa gauge, or an absolute pressure of 210 kPa or 2.08 atom, on a normal Merlin 50 engine. Merlin 50 series was first to use the Bendix Stromberg -G carburetor. 1 Merlin 61, RM8SM. 1565 HP, 1167 kilowatts, at 3000 RPM at 12,250 feet, 3734 m, 1390 HP, 1040 kilowatts, at 3000 RPM at 23,500 feet, 7,163 m, fitted with a new 2-speed 2-stage supercharger providing increased power at medium to high altitudes, plus 15 psi boost, used in Spitfire FMK.9 and P.RMK.11.